Hi everybody, so in today's lesson we're going to be graphing coterminal and reference angles. So we're going to be introducing two new vocabulary terms, the first one being coterminal angles. So what is a coterminal angle? Well, we've got the definition right here. So a coterminal angle are angles in standard position with the same terminal side are coterminal angles. Give two coterminal angles for each given angle, one positive and one negative. So let's discuss this. So coterminal means basically the same angle. Okay, it's in the same position, just a different value. Okay, so what I want to do first is I want to go ahead and explain this. So before we start graphing like we're going to do here, let's go ahead and start labeling. So we know that this is 0. We'll say this is 90, 180, 270. And for 65 degrees, this is all we're going to need here. So when we're doing 65, we already know that it's positive, so we're going to be going in a counterclockwise way. And 65 is going to be between 0 and 90. So we can say this here. So we're looking for coterminal, which is just another way of saying same position, just different value. And we're going to be wanting to focus on one positive value and one negative. So I've labeled, like we've done there, and I've sketched. So how do we get this? Well, we know that one rotation is 360 degrees. So if I take this value of 65 and I rotate it a whole 365 again, we should be in the same spot. So how do we do that? Well, we would take 65 degrees, and we're doing here step 3 right now. We're taking 65 degrees and we're adding 360 to that. Well, 65 plus 360 is 425 degrees. In other words, 65 degrees and 425 degrees are in the exact same spot. It's the same coterminal angles. And this satisfies a positive coterminal angle. How do we get a negative coterminal angle? Well, we start with the 65 degrees, but this time we're going to be going in the clockwise way. In other words, we're going to be subtracting 360. So we'd say 65 minus 360, which is going to give us negative 295 degrees. So we have our positive and we have our negative coterminal angles. And step 5 says make sure you have one positive and one negative, which we do. If not, add or subtract 360 again. Now this could be in either way, and we'll get to a couple of problems that involve that. Okay, so for 65 degrees, your answers would be 425 and negative 295. Well, let's do 540. This is again positive, so we're going to be going in the counterclockwise way. We want to make sure we label our spots at 0, 90, 180, 270, 360. Now 540 is greater than 360, so we're going to want to keep labeling. We know that we're going to have to go to 450. We're going to have to go a little bit more. We know that 180 is going to be the equivalent of 540, and we can stop there because our value is 540. So what's happening is we went around once and we came here, and our angle actually is right here at 540. Well, how do we get our coterminal angles for this? We're going to follow the exact same steps. So we would take that 540 and we can add 360 to it. Well, 540 and 360 equals 900 degrees. Okay, and now if we want to get our negative coterminal angle, we would do the same thing that we did in the previous problem. We'd say 540, but minus 360. Well, 540 minus 360 is 180 degrees. Now the problem with this is we need a negative coterminal angle. We didn't get a negative, we got a positive 180. So this is where we go into step 5, where we didn't get that negative value. So we're going to take that 180 and we'll subtract 360 again. And this will give us negative 180. So now what are our answers? Well, our answers, You could, for the positive value, you could either pick the 900 degrees or the 180. I personally like the numbers closest together. I would go ahead and pick the 180 and the negative 180. These numbers work. Now, if you said 900 and negative 180, you're technically correct. But we're going to go with these two here. Okay? And for negative 40, well, when we go negative 40, remember we start here at 0, so we're labeling negative 90. We can stop here because we know that negative 40 is going to fall between 0 and negative 90. That's somewhere right here. Okay, we just went in this direction. So when we're looking for our coterminal angles, we start off with negative 40, and we'll add 360, and that gives us 320. Okay. Then we take the negative 40, we can subtract 360, and that'll give us negative 400. Well, we have a positive coterminal and a negative coterminal, and that satisfies that. So if we go in the negative direction. All right. Let's do a couple of more just to be on the safe side here and give you more exposure. So let's look at the negative 540. So with the negative 540, we're going to do the same. We're going to go ahead and label at 0, negative 90, negative 180, negative 270. Then we come around to negative 360. Well, we need to keep going because negative 540 is not, it is beyond this negative 360. So we're going to go negative 450. Got to keep going to negative 540. That's where we're stopping. So what's happening is we're spinning around to here. And this is our angle. What do we do with negative 540? Well, to get our coterminals, we'd start off with the negative 540. And let's go ahead and add 360 to that. We get negative 180. So we already have a negative here. So hint, hint, you're not going to want to subtract the negative 540 minus 360, you're just going to get a negative. So we're going to take this negative 180 and we're going to add 360 to it again, which would give us a positive 180. Okay, and these would be your coterminal angles. So let me jump back because I kind of jumped the gun there. All right, let's talk about the subtraction. What if we did do that negative 540 minus 360? Okay, if we do that work, we're going to get negative 900. Now you could use negative 900 as an answer, and you could say your coterminal angles would be negative 900 and positive 180. Okay, just remember though, I think it's best practice to have your two coterminal angles be closest to 0 as possible, which would be the negative 180 and the positive 180. Okay, let's do one more together. That's 710. What we're going to label 0, 90, 180, 270, 360. Got to keep going at 450, 540, 630, and then 720. Well, 710 is like right before, so we're coming here. So what's happening is we do one whole turnaround, one loop, and almost there. We stop. Same steps. We're going to go ahead and take that 710, and we can add the 360. That works. And you're going to get 1070. And then when we subtract, we'd say 710 minus 360 equals 350. Now we can't stop there because we got a positive 350. And if you remember correctly, we need to make sure that we also get a negative value. So we're going to take that 350 and we'll subtract 360 from it again. Here we get a negative 10. So for sure, negative 10 is one of our answers. Now you could pick the 1070, but it's best practice to pick the 350 as it's closer to 0. So these are our coterminal angles. You're adding or subtracting 360 until you have equivalent angle indicators. one positive, one negative. Okay? And those are coterminal reference angles. I'm sorry, just coterminal angles. So now let's discuss reference angles. So this is our new vocabulary word, our second one for the day. So what is a reference angle? So it says for an angle theta in standard form, the reference angle is the positive acute angle formed from the terminal side and the x-axis. Sketch and find the reference angles for each angle. Okay, long story short, this is just the angle off the x-axis. It's either going to go up, or you could have it here. You find this guy and this guy. Now, what I want to make sure that we're very clear is you're always going to get positive answers for reference angles. Hint, hint on your assignment. If you see any negative values in your multiple choice for your reference angles, that is obviously not going to be correct, as your reference angles always have to be positive. Positive. It's in the definition. Okay? So let's go ahead and work a couple of these out. Let's look at 225. We're going to go here. We're going to label 0, 90, 180, 270. We can stop here at 270 as we know that our angle is going to be in between those two there. So at 270, we're going to come around and, I'm sorry, 225, we know it's going to be somewhere here. Okay? So that's our 225. Now we're looking for this angle. It's the angle between our angle itself and our x value. What is this? So what I like to tell students is you take that value and you're going to be subtracting whatever that x-axis value is. Okay? So in other words, we're going to say 225 minus 180. Okay? So that's going to be 45 degrees. In other words, between here and here, it's 45 degrees. Okay? That is the angle distance there. So let's look at 310. Well, on this side, we're going to be going counterclockwise. At 0, negative 90, negative 180, negative 270, negative 360, and we can stop there. So we know that we're going to have some type of angle in between here at negative 310. Okay? So at negative 310, we're going to be looking for that angle here. So it's the change between the 360, the negative 360, and the negative 310. So we can say negative 360 minus negative 310. Well, negative 360 minus negative is positive 310. And that's going to equal negative 50. That can't be true for this, as our angle has to be positive. Well, we just make that positive. We know that we're going to have 50 degrees. In other words, if we were to take this angle and this angle, you would get 50 degrees. Okay, again, reference angles is just the angle between the indicator and that x-axis. And for our last problem, we're given 2 pi over 3, which would be 2 pi over 3 radians, right? And so there's two ways of doing this. We can go ahead and convert these radians to degrees, or we can evaluate this with just radians. We're going to do both, actually, to help make that connection. So let's go ahead and convert this to degrees, and we'll say 2 pi over 3, and we'll multiply that by 180 over pi. And we know this from the previous lesson. We're going to go ahead and work this out. We're going to get 360 pi over 3 pi. We'll simplify this out. We know pi over pi simplify out, so we're going to be having 360 over 3, which reduces down to 120 degrees. Okay? And so when we graph that, we know that, well, here we have 90, here we have 180, so our 120 has to fall about here. Okay, this would be 120. Well, we want our reference angle, which is this guy here. What is this guy? Well, to get that reference angle, we would take the 180 minus the 120. So we'd say 180 minus the 120 is equal to 60 degrees. So this guy is 60. Okay, so our reference angle is 60. Well, what if we used it as just radians, right? So with radians, we know that here is 0. We know that 180 is equivalent as pi, and we'd have pi over 2 at our 90-degree angle there. So that means that our angle that we're going to get here is going to fall in the same area as 2 pi over 3. Okay? So when we work this out, essentially what we're doing is we would say pi minus 2 pi over 3. That's just like saying 1 minus 2 over 3, which is 1/3 pi. Well, if we can convert 1/3 pi, we can say 1/3 pi times 180 pi equals 180 pi over 3 pi. This looks very familiar. Okay, we know that these will simplify out. We're going to have 180 divided by 3, which equals 60 degrees. And that's what's left here at our 60 degrees. That would be our reference angle there. Either way, I'm fine right now with the course. You can go ahead and convert to degrees or solve it as radians. I know a lot of this is so very new to everybody in this course, so I strongly recommend that you guys hop onto my office hours. You guys already know that's happening at 9 and at 1, so hop on there. Don't forget, you guys do receive extra credit, so please send me your messages, get on these calls, let's do some math, and let's have a good day. We'll talk to you all later. Bye-bye.